Hello, welcome back to my stream, day 16 of Advent of Code, and I have to figure out how to play around with audio levels. But before I do that, making sure that I'm unmuted, unlike yesterday, let us transition over to our display and figure out how to dive right in. Yesterday was interesting because we had ModProg on the chat, and I did actually get a PR, which maybe we can take a look at once. No, that's not it. Here. I got a PR here, and I glanced over it a bit, but maybe we can look at it on stream. But I don't know how long day 16 is going to take, so let's first, before we start anything, or before we start looking at this, we will look at day 16 and solve that one, he says, with great hubris. Okay. Day 16, Packet Decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. Transmission was sent using a buoyancy interchange transmission system, BITS. Method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal, your puzzle input. The first step of decoding the message is to convert the hex to binary. Okay, it's just standard hex to binary. There's nothing fancy here. Nope. Okay. The bits transmission contains a single packet as its outermost layer, which itself contains many other packets. Oh, okay. Nested packets. Hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Alright. That might throw a little spanner in the works. Every packet begins with a standard header. The first 3 bits encode the packet version. The next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packet are represented as binary, with the most significant bit first. For example, a version encoded as binary sequence 100 represents number 4. Okay. Packets with type 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits. And then is broken into groups of 4 bits. Each group is prefixed with a 1 bit, except for the last group, which is prefixed with a 0 bit. What? These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes this. 3 bits labeled V, the packet version. Okay. 3 bits labeled T are the packet type. Okay. And the 5 bits here, these are the A's here. Oh, it's 4 bits plus a 1 bit, 4 bits plus a 1 bit, and then 4 bits plus a 0 bit, indicating the end of the number, and then discard these guys at the end. Okay. Three unlabeled 0 bits at the end are extra due to the hexadecimal representation and should be ignored. So this packet represents a literal value with a binary representation that, which is 2021 decimal. Okay. Every other type of packet, any packet with type ID other than 4, represents an operator that performs some calculation on one or more subpackets contained within. Oh, okay. So are we making a expression tree here? Yeah, and now this feels like the kind of puzzle that once we solve it, the next day or maybe in a couple of days, there's going to be... Remember that thing you did back on day 16? We're going to extend that. All right, an operator packet contains 1 or more packets. To indicate which subsequent binary data represents its subpackets, an operator packet can use one of 2 modes, indicated by the bit immediately after the packet header. This is called the length type ID. The length type ID is 0. The next 15 bits are a number that represents the total length in bits of the subpackets contained by the packet. The length type ID is 1. The next 11 bits are the number that represents blah, 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 blah. Finally, after the length type ID bit and the 15 or 11 bit field, the subpackets appear. For example, here's an operator packet with this hexadecimal string with length type ID 0 that contains 2 sub packets. Alright, so here's I, which is the length type ID. It's a 0, which means that the length type is a 15-bit number, which is all of these guys, saying we have 27 bits left in the packet, or left in this particular sub packet. 11 bits labeled A contain the first sub packet, and 11 bits represent the second sub packet. Okay. Okay. So then this is a packet in and of itself. Oops. This is a packet in and of itself. A literal value representing the number 10. So that means these first 3 are the version, these next 3 are the type, and then we have 5 more. Yes, with a 0 in the lead representing the fact that this is the final digit. It's a number 10. After reading 11 and 16, the total length indicated by an L, and then we stop parsing. So we know that all these zeros get discarded because we've used up all 27 bits here. All right, as another example, here's an operator packet with blah, 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 blah. We got a version, we got a type. Type is 3. We have a 1 now, which means that there are 11 subpackets. Oh, no, sorry, 11. 3. 11 binary, so 3 subpackets. So then here's 1, 2, and 3 subpackets. And I guess we ignore those because there's only 3 subpackets. Okay. After reading 3 complete subpackets, the number of subpackets indicated in L is reached, so parsing of this packet stops. For now, parse the hierarchy of the packets throughout the transmission and add up all the version numbers. Alright, so just saying, can you figure out how to parse these packets? So we have a bunch of test cases we can actually write. Right, there's one, the little tiny guy up here. Yeah, this guy. And there's this longer one here. And then we have these additional 4 that are down here. So once we've decoded it, what do you get if you add up all the version numbers? Okay. And I'm guessing our puzzle input's very long. It is very long. Okay, so input day16.text. It looks like it's just a single line. Yeah, it's just a single line. Okay. So downloads input day16 into inputs. And we can say marker source day16. Source main. We're going to add day16 here. Oh, and the other thing I wanted to have time for is I have a couple of bugs I want to fix in this logic here. If there's time. I don't know how long this is going to take. This could take a while. Depending on how stuck I get. Right? Okay, so this should fail because... Nope. Should fail because day16 doesn't exist. Day16 log.rs. Print that out. Make sure this checks. Make sure it runs. We get day16. We do. Okay. So what do we need? What supporting functions do we need? We're going to need a function that converts these hexadecimal strings into a list of binary numbers. And then we'll need a function which reads subpackets. And it looks like we're going to have to do something recursively with this because packets can contain packets which can contain packets. So this is going to be... Let's start by... Because we do have some test cases. Let's write tests. And our first test is going to just see if we can decode, what was that little guy up here? D2FE28. Let's see if we can decode him into this binary string here. Decode, can decode hex. And what we'll do is we'll say assert EQ, decode hex. this, and it's going to be a vector, I guess. We'll just turn it into a vector of that. And then we got to add commas. Like that. No, it's not going to fit on line. That's okay. It doesn't need to fit on line. Okay, so let's just put that there. Put that there. I don't know what we're going to get in terms of formatting. All right, so let's see if we can run our tests. Of course, decode test hex does not exist, so let's write it. Test-driven development at its finest. Decode hex, and we're just going to say hex is going to be a string and it's going to return a vector of U8s. So now what we need to do is go character by character through this hex thing and convert it. And we could set up a little table, or we could make a little, yeah, so what we'll do is say for C in hex chars, we have to say let value equal if C is greater than or equal to the letter A. Are these all uppercase? I think they're all uppercase, and I think our test data, let me just check our test data. Day 16. Yes, it's all uppercase. So that makes it, we can just do it this way. We don't have to check lowercase a. Then we're going to say value is C as U8 minus A plus 10. Else C as U8 minus 0 without adding or subtracting from that. Okay, so now we have a value. Now we want to create a vector. Let results equals back new. And what we'll do is we can loop over each one of the bits. For B, for bit in 8, 4, 2, 1. We're going to say result.push C and B is not equal to 0 as U8. And then just say result. And that should convert all the bits. Right? Because if C and B, so C and 8, C and 4, C and 2, C and 1, if it's not 0, then we're going to say that's a 1 bit and we're going to push that. So hopefully this will check. It won't. Oh, it's a char versus an integer. Oh, right, value. Value in B. And that doesn't like that either because it needs to be mutable. And that checks. Let's see if it tests. Oh, I forgot my super. Use super star. Oh. Test. Okay, so there it is. Can decode hex passes. So now what we need to do is write a... We have to write it. We have to do the thing. Okay, so there's no simple like stepping stone we can use. We should just use this decode hex thing and then see if we can. We're going to add up the version numbers, and this one only has one version number. So function some versions, because we have more than one. And how are we going to extract data? I'm trying to think of the way to extract data from these things. Maybe. Okay, well, how would we do it? Like if we had our bits, which is a vec of U8, and I guess it's going to return, let's do things with U64 today. Why not? We have bits. We can create an iterator. And then what we can do is get the version number by saying let version equals iter.take3.fold bit, and it's going to be ACC shifted by 1 or the bit. And we want this to be a U64, so this is going to have to be as U64. And then for now, we'll just return version and see if we can decode the version number of this guy here. So let's copy this. Simple version. And what we'll do is we'll say let Becca's decode hex, and let's say bits. Decode hex, and then we'll say assert EQ, and we can see that the version number is 6 here, 110, and they actually say it right there, so we should be able to say some versions of bits is equal to 6. And what, it doesn't like that. Oh, I have to put a star there. Okay. Simple version. So that worked. So we were able to use this fancy thing to get the version number, but we don't. That would be really annoying because I have to do it for every single thing, right? I have to say, okay, now the type is this, and then the 5 bits I have to take and... is there an easier way to do this? Why don't we play around with traits? Because then I could say, I can use the iterator, right? And then I can say iter, let me just say bits to num, maybe, of 3, and then it just give us all of this. Right? Maybe we can make a trait which does that on an iterator, and then we can implement that for the iterator. Stop that. All right, so that's that. So let's make this trait bit reader, and it's, what do I call it? Bits to num, and it takes an iterator. Oh, I don't know what the type of that is, but we can find out. Let's comment that out, comment that out, comment that out. If I just try to compile this, it's going to tell me the type. It's this type. Okay. So I can say use this star maybe, and then say trait bit reader function bits to num. It's going to take a biterator. Haha. And it's just iter of tick underscore U8, and it's going to return a U64. And then we're going to say impl. Oh no, it's just going to take a, that's not the way this works. It takes a self and a count, like that. And it'll return a U64. What we're going to do is say impl bit reader for iter this U8. That's how this works. And then this is going to be bits to num. Oh, it's got to be mutable, right? Because we're going to mutate the, we're going to iterate on the iterator. Self count U64 returns a U64, and what we're going to do is, oh, I deleted my, where did, is it in one of my, no, I was trying to see if it was in one of my buffers. What the hell did I just do? That was from yesterday. Okay. But we can re-implement it, right? So we say self.take of count, fold, starting at 0, accumulator and bit is accumulator shifted by 1 or bit as U64. And that's it. That's the whole thing. And now we should be able to just say bits to num 3 here and return version, and didn't work. Expected U size. And star. I forgot the star again. Okay. So we have 3 warnings, but let's see if those tests pass. They all pass. Okay, so we actually now have a trait where we can just say bits to num 3 on our iterator and we get the version. All right, but we want to make this a recursive function. So to make this a recursive function, we actually have to just create something that takes an iterator, so we can just keep passing the iterator to it. I think that's the approach we need to take here. So we have to create we have to make up a function name, get version sum, sure, of the iterator. Oh, and it's got to be mutable. We got to pass in a mutable iterator, and that's just going to return get version sum. It's going to take the iterator in. Iter, it's going to be a mutable iter tick underscore u8, and it's going to return a u64. And then we get the version right at the top of this packet. So now we're on, we could be in the full packet, or we can be in a sub packet, because we're going to call get version sum recursively. But for this version, it's this packet. Then we have to decode the message type. Message type, right, is the next 3 bits. And it's saying, what was it? It was packet type 4? Yeah, packet type 4 is a special literal value packet type. So if message type is 4, then this is the literal. And I'll do that in a second, because right now I just want to think about the structure of the program here. Otherwise, it's this length type ID is the next bit, right? So we've done the VVV, we've done the TTT, now we need to grab the I. So this is the length type is going to be iter bits to num1. Sure, why not? We grab 1 bit, and then if the len type is 0, then the next 15 bits are the number that represents the total length in bits of the subpackets contained by this packet. So let subpacket len equal iter bits to num 15, right? And then we'll do something with that. Subpackets, and then else len type must be 1, because we only got 1 bit, so it's got to be 1. If len type is 1, then the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. So that's how many packets there are. The subpacket count is iter bits to num 11, and then we'll do something. Subpackets, right? And then what we'll do in here is we're going to add up, this will be version plus equal, oh, so we have to make it mutable, and this will have a version plus equals something. All right, and we just need to figure out what these somethings are. All right, so let's do these one at a time. The literal is pretty straightforward. We have to grab 5 bits at a time, and if the top bit is a 1, then we keep going. So, and we don't actually need the, for this version something, we don't need the number. We just need to consume these bits. So we can say while iter bits to num of 5 is greater than 15. Consume the bits. And as soon as it isn't, why isn't that lining up? Because we don't have to do anything. We just consume the bits. And then we're done. And there's no version number or anything like that, so we don't have to add any version thing in there. All right, that was pretty straightforward. Does this check? Oh, yeah, of course it doesn't check. Okay, because we have the next thing to write. So if subpacket length, this is how many bits there are in our subpacket. So we're going to get a subpacket all the sub packets. It's going to be our iter, and we're going to just take the sub packet length and collect that into a U8. And now we want to create a new iterator. From the sub packets. And then you say version plus equals get version num. Oh, I just thought of something that I'm not taking into account here. Let's finish that. Well, something I'm not taking into account was this first thing, this thing here, where we actually have a sub packet. This is the length of the sub packet. All right, 27 bits. And then what I'm doing is I'm just looking at the first one here and then I'm exiting. I need to keep looping over all the bits in the iterator until the iterator is consumed. Right? Because we need to get both of these guys. What's the there's a function rust iterator empty. Is that what it is? I guess we can iterate until we get back a none. Oh, that's just an empty iterator. That's not is empty. Is empty. Can we do that? Slice stir. This is all of them. Exact size iterator is empty. Into iterator is empty. Well, we can see. Let's try it. So let mut version equals 0, and then we'll loop over here while iter not iter is empty. Then we're going to go here, shift these in. We'll say version plus equals this, that. And does that work? Okay, so it didn't complain about the is empty. Let me change that to a 1 and see. No, it didn't like. Exact size is empty. Yeah, okay. And then we have some other issues we need to keep track of. What can we do here to see if there's anything left in the iterator? Standard slice iter. Are there any good functions that we can... As ref, clone, format, next, nth back, rfold, rfind, len. There is... Okay, it's a nightly only experimental API. I don't want to run with... Tests any element. No, we don't want that. Find map position. Our position is sorted by. Intersperse. Oh, look at all this stuff. Peekable. Can look at the next element of the iterator without consuming it. By ref. Collect is partitioned, fold, reduce, find, min max. Because I don't want to steal the first, I don't want to pull the first bit off of it, right? I just want to see, are there any more Are there any more? And I don't want to have this thing return an option, because then I'll have to unwrap every single one of them. Right? Maybe that's the way we got to do it. Is we say, you know, if let sum, I don't know, is there a while let sum? Does Rust have while let sum? Rust while let sum. Oh, while let does exist. Okay. Okay. So maybe that's what we do, is we return an optional. Although this, if we do a take here and then a fold, what happens if we run out of bits? Because this is not saying it's returning an optional thing. What happens if we try to take too much? All right, so this doesn't work because it is empty. Let me just say loop. And if this fails, then we can break. But I just want to check this. Ooh, forget version num. Forget version sum. This was supposed to be as usize. And oh, we can't collect. Oh, from oh, what was the? There was a thing that began with the letter C. That saved me from having to do this, map x star x. All right, that checks, but I can't run this now because this is an infinite loop. What I wanted to do is just check bits. What happens if bits to num runs out of bits? Yeah. So if I create a new, let's comment these guys out. Otherwise, those will loop forever. And then we'll say test bits check. And we'll say let v is a vec of u8 is a vec bang of 1, 1. So if I say now let mod I equals v dot iter, what happens when I say assert eq I dot bits to num of 3? Is that going to be equal to 3? Or is that going to fail? It checks. What happens if I try to run it? Bits check. Oh, it just consumed it and then it kept going? What happens if I do it a second time? Okay, so then it came up with 0. So it's not telling me, oh, the iterator ran out. Which would be nice to know if the iterator runs out of bits to iterate on. Is there something in here where we can say take Rust iter take where's take? This is take. There we go. It's just going to return none for the remainder, and we just have to be aware of that. There's no way to just stop. That's scan. Yeah, I don't know. I don't know what's the right approach here to figure out that you've run out of the iterator. Is it peekable? Because I saw that peekable thing there. Standard iter peekable. Okay, so we can say peek. Let's see if that works. We can say that if iter.peek is not equal to none. Actually, while iter.peek is not equal to none. Okay, will this check? It will not. We can't make it peekable. Oh, we have to make it a peekable iterator. Creates an iterator which can use peek and peek mute methods to look at the next element without consuming it. So can I do that here? It creates the iterator off of that. Okay, so it can say peekable. Does that work? Okay. So what type is that? Let's see if we can figure out the type. Decode hex. So we're going to just say peekable. And now is it telling? Oh, I messed that up. Found struct peekable. That's all it is. It's just a peekable. Okay. Does that actually do the trick? Oh, and then we have to use standard. What is it? Where is it defined? Standard iterator. Expected one generic argument. Okay, so U8? U8 is not an iterator. Oh, okay, so this is where we say iter tick underscore U8. And now we have to implement that this way. Okay. Make that peekable. And then now this doesn't like it because it has type peekable while... Oh. Now I can't do a take on it because it's peekable. How do we get the inner type of the thing that we can run a take on? Let's see the example here. But we can't run peek mute. Lets us look into the future. We can get mutable. We don't care. I don't want a mutable one. I just want to be able to... The value appears as the iterator continues. Okay, so Rust peekable take. Can I do that? How to use Rust's peekable? This fails to compile. Right. So what's the answer? Make it peekable. By ref. Peekable I, right? Okay. Not seeing that. Next based on the result of peekable peek. But I want to use take. And that's not gonna Peeking take while. I have to add a new crate for that. Iter XS by ref take while. And this is a peeking take while. Because it's peekable. I mean, I could just make this a loop, but that would be annoying because this is kind of a nice line of code. Okay, Let's make it a loop. For in 0.count. I should be able to say that bit equals self next, right? That should still work. Let accumulator equals 0, and then accumulator equals accumulator shifted by 1, or bit star as U64, and then return accumulator, which is just what this code was doing, just the long way around. Oh, option U8 can't be unwrapped. Oh, this is where it's going to blow up if we go too far, right? Camp bar is mutable. Oh, this has to be mutable. Okay, and then bits to num. Method not found in this. I thought I just defined it up here. Oh, I defined it for mutable, not for immutable. Oh, this was nice, and now it's terrible. Yeah, so now it's saying this. So this is looking for this code, but this needs self to be not behind a reference like that. So, all right, so we don't have peak. Is there another way we can... Let's undo all the peekable stuff. Where's the other peekables? Get rid of all these peekables. What did I mess up here? Found a mutable reference. Oh. And we don't have peak. And I don't want to say iter next because that's gonna steal a bit. I guess we can, and then just OR it onto this thing and just say 2. That's frustrating. While let some value equals iter next. Version is equal to value shifted by 2 or that. That's annoying. Uh-oh, method not found. This was working. Did I break it now? Oh no, I should have saved it before I did all these changes. There's bits to num right here, and I implemented it for that. Oh, for mutable standard slice. Yeah, we still need a mutable vector. A mutable iterator. Wait, what did I do wrong? This was right before. And if I put a mute back here, it's going to fail. Expected U8, found U64. Okay, that's because of this thing. Cannot borrow as mutable? Why not? Mute iter. Really? Okay. Do any of the tests still pass? Of course not. Yeah, look at this. What the hell? What did I break? I added this extra peekable, so let me cargo clean. That's going to rebuild everything. unfortunately. This one started out as fun, and now it's being okay. So cargo built. Let's just nvim day 16. We are on day 16. This wasn't supposed to be this difficult. Cargo check. There we go. Okay, yeah, it's working, and there must have been something in the cache or something like that that got messed up with all my peekable and non-peekable stuff. Get rid of that mute and see if it still works. Nope. That has to be there. And if I try to run the tests, it's going to fail. Oh, damn. Damn, damn, damn. The method is available for mutt slice here. Okay, so if I change that, what if I do it this way? Let rest equals, and then or rest. And, oh, it is U64. Okay. No. And if I put this here, it's not going to work. So why didn't I need both last time? What did I'm going to have to go back and look at what I did, because now I'm very confused. And this isn't going to work because you can't move out of self. We didn't used to have a mutt here, I believe. But this was the mutator here. So let me get rid of this one here, because I didn't think I needed it here. And now this doesn't work. No method named bits2num found for mutable reference in current scope. Yeah. This was all working, and now it's not. I got to see what I broke. Let's see. This is a mutable iterator. This is a mutable iterator. This is taking on mute. It was after this, right? Yeah, B is not found in scope. Okay. Yeah, okay. So am I doing something weird down here? No, just v-iter and I bits2num, and then does that fail down here? What line is this? Line 89? No. Oh, man. Okay. Trying to think of what I could have broken when I did the conversion over to peekable, and now it's not peekable anymore. I don't have any peaks anymore, right? And that's not that. That's not that. I mean, it should be blindingly obvious as to what mistake I made, and it isn't. We can decode hex here. Let me write a quick test. Just all we do is that one thing is bits2num on the iterate. Oh, I already have that. So let's comment these out and do that. and then do this, and then comment out some versions and get version some. And where does this fail? Yeah. So this is the, oh, it does not implement the copy trait. So this is the code I thought I had before, where in which we were, let's comment this out and then see what the type is of that thing. If I say run the tests, yeah, so method not found in standard slice iterator. Oh, is that the, is that? Okay. So that's what I broke. I had an extra ampersand in there. So delete that. You can add those. This test we don't want to do. All right, so does this test? Yeah, okay. So that was a mistake. But anyway, back to the real world. So we want to keep iterating until we run out of bits. But we also have that condition where we have zeros at the end of a packet we want to ignore. So how do you end up doing that? Right, this is the 27 bits, right? Let me just check that. I'm just going to paste it here and say yes, we have 27 showing down here. So what'll happen is we call this function. We're going to grab that first bit. We're going to grab the other two bits from the thing. We'll grab the type, we'll grab the I, we'll see there's 27, and then we'll call this thing with our 27 bits. This will loop here. It'll grab the first literal, the first packet, it'll grab the second packet, it'll sum up the versions and return those because we'll run out of bits. And then when we come back here, there's still going to be these bits left. So I wonder if it's true that there's a single message packet which contains subpackets. So we want to say if we're on the first subpacket, we don't want to loop. Maybe that's the way we can break out of it. Bool, first bool, and this will just be true. And then every time we call get version sum, we'll just pass in false. And then down here we'll say if first break. That's kind of sloppy, but it gets the job done. And this is sloppy too. Let's see if our tests still pass with that. They do. Yeah, we're not using subpacket count. Okay, so we have those. Let's see if, we got to figure out, we don't need to do this part. We do need to do this part. So we have a subpacket count. Now we have a certain number of packets we're actually going to be consuming. So we can say for 0 ... subpacket count version plus equals not 1, but we can say version get version sum. What are we passing in? We're actually passing in same iterator, right? Because up here we grabbed a new iterator because we pulled them off of the packets, but now we actually want to continue processing the current packet, right? And is this all we need to do for this? I think so. And let's add a test where we have this, right? So let's add this test where we're going to do this. So let's copy that string over. And this one has, let's do this one first. Since it's one higher up, maybe it's a simpler test to do. And this one has it's called a double packet. So let bits equals decode hex of this. Assert EQ, some versions, bits is, it doesn't tell us what the version is. Okay, but we'll have to add it up ourselves. It's going to be the initial version, which is 1, plus the version of this packet, which is 6, plus the version of this packet, which is 2. Okay, and that doesn't work. Oh, I forgot to put the word in. And we can't do this. Oh, this is false. It's not the first packet anymore. Okay, so test. And I forgot the bang, because I always forget the bang. Some versions. I guess it's one of the frustrating things about tests is the Control D check this one. Oh, okay. Where is it? Everything passed, so there it is. Double packet passes. Double packet passes. Let's see if this one passes. And this one has, looks like 3 sub packets. That's what we'll call the test. Test fn3 sub packets. Let bits equals decode hex of this, like that, and then assert equals, and now we have to add up our versions. And it's going to be 7 for the first one. And then we have a subpacket here, which is going to be 2. A subpacket here, which looks like 6. Oh, sorry. What am I thinking? That's a 4. And then this one is a 1. Okay. Let's try that test. Okay, that worked. What else? Okay, now we have these 4 and they actually tell us what the sums are. So we can add these guys. Test fn, and this contains operator, which contains an operator. So this is going to be double recursion. I should just copy and paste the code. I'll do that next time. Do that, and then here, instead of that, it's going to be a 16. Okay. Test. That works. The next one contains 2 subpackets, and each subpacket is an operated packet that contains 2 literal values. So we'll call this a 2 plus 2. And it's this thing here. And the total is 23. Test. And it failed. We got 12 instead of 23. Can I do cargo from here test 2 plus 2 to just run that one test? Yes. Okay. So I'll have to just do that because now I'm going to add some output and find out what's going wrong. So this is going to be an operator packet version 3. And then we're going to get, it contains 2 subpackets. Each subpacket is an operator packet that contains 2 literal values. And it should sum to, it should sum to 12. I missed that. I was looking right down here. I was looking at the wrong one. Okay, so that worked. Let's just change this to 12 and move on. All right, so this test, This is going to be the same structure as the previous one, but the outer map packet uses different length type ID. Okay. Different length. And this is going to be this guy here. And instead of this one's the 23. Okay. I keep doing cargo check even though it's not going to do anything. Okay, so those all pass. And finally, we have a 31 here. And this is going to be an operator packet. It contains an operator packet, contains an operator packet, contains 5 literal values. Okay. So this one's going to be triple nested 5 values. And again, I forgot to do a copy paste. And then just assert equal. And this is going to be 31. And hopefully this works. And it does. Okay, so now we can try it on our real input, which means we have to write the code that does the real input. So use create utils read file, I think I called it. And let lines equals read file input day 16.text. And it's just one line. So we're going to say println day 16 part 1 is this, and it's some versions of lines of 0. 2 of those and probably an ampersand. Nope. Some versions. And expected evec. Oh, I have to decode. Let decode equals decode hex of lines of 0. And then we'll pass in decode. All right, so let's run this. And it panics. Oh, did I forget to move it into place? Did I mistype it here? Oh yeah, I did. I forgot to put the directory. Okay, let's try again. We got 960. Sweet! Okay, that's part 1 done. Let's clippy this and check it in. Okay, and then this. Yeah, copy. That was the C method I was thinking of. Okay, let's make these changes. On line 37, we'll just change it to a slice. And then this big guy here becomes copied. Oh, I need this. I still need the collective. Duh. Collect. There we go. Okay, and that should still run. Gives us the same answer. Clippy's happy. Git add source and inputs. It's just that, right? Git commit -m day 16 part 1. Push. Okay. That took an hour. I'm surprised actually because that was kind of a straightforward thing. I didn't have to think about Dijkstra or A star or anything like that. Yeah, look at this, another wall of text. Okay. Part 2 is now that you have the structure of your transmission decoded, you can calculate the value of the expression it represents. Yep. I kind of guessed that, unfortunately. Okay, so that means we have to actually, instead of doing all this, we're not just returning the version sum, we also have to do all of these things. Literal values represent a single number as described above. The remaining type IDs are more interesting. So for 0, 1, 2, 3, 5, 6, and 7, each one. Yeah, so this is yeah, we're doing calculations. Now, I don't want to break this code, right? So maybe what we can do is just change it to calculate and return the version sum plus the results that we're actually calculating. Right, so we basically return a tuple here. So instead of some versions, we can just call this calculate and calculate packets. And this is going to return a U64 and I'm going to say I64 for the value, because we do subtract, right? Sum product, minimum, maximum, greater than. Oh, we don't. There's no negatives in here. Okay, so let's just do. And this might bite us in a subsequent day, right? If we just do U64, but that's what we're going to do. So calculate, and this calculate packets, and then instead of just a version, let mute value, right? We're not using that. And then down here, we just return the version and the value. All right. So instead of consuming the bits, we're actually going to calculate the value of this packet. Oh, that's interesting. If there's two literals, right, there's this one packet here. The reason I'm pausing is because here's a packet that has two literal values. Oh, no, not there. Yeah. Oh, but it's a type 6, and so it grabs each literal value separately. Oh, and all I'm doing is grabbing it and then grabbing the thing. And what I need to get back from this is each individual. Oh, man. We have to get back each individual component so that we can sum them here. Packets ID 0, their value is the sum of the values of their subpackets. If they only have a single subpacket, their value is the value of the subpacket. So when I do this, I want to actually return a list of all of the subpackets. And when I do this, I want to get a list of all the subpackets. This one we can do easily, right? Because we're looping over them. So we can get all the individual ones together. And then apply an operator to them. Yeah. Oh boy. So how do we want to break this up? If we have a function which decodes a single packet, and then when it returns, the iterator will already be ready to go for the next packet if there is one. Right, this is, but this has to be recursive because of the way it's designed. And so if, for example, if the message type is 0, we want to get all of the subpackets here either way, and then just add them up. So how can we do it this way? Let's think about what we can do to change this that'll allow us to get back a list. So all we have is the length of the iterator. We don't know how many packets there are in it. This is going to be easier. Let vsum and valsum, version sum and value sum equals get version sum this, and then we can just say version plus equals ver sum and value plus equals val sum. And up here we can do this and convert the you can say let's say value equals that, and then we can say, oh, we don't want to use value, we want to say digit, I guess. It's not a digit, it's a nibble. And then we say if while digit is greater than 15, value plus equals digit, and it's just the lower 4 bits, right? Oh, no. Let result equals 0, and this is going to be result is results shifted by 4, or digit and 4 F. And then value equals, oh, so yeah, so maybe value is a list of U64s. Maybe that's the easier way to do it. Value is vec new, and then we just say value dot push result, and then we return that and the value. And this here, we'll just say value dot push. Oh, but valsum, it's extend, right? Valsum. I think that's what it is for vectors, right? You can do rust vec extend. Oop. I thought you could. Extend from slice, extend from within. Is there just a regular extend? All right, it'll tell me. Oh, right. Yeah, no, this doesn't work anymore. Calculate. Get version sum not found in the scope. Oh, yeah. Now it's called calculate packets. And now I need to print it out this way. And this needs to be the vector as well. Although it should, the result should just be, I'll clean that up once we get done, if we ever get there. Where are we? Oh yeah, and this is calculate packets, so let ver sum val, I shouldn't call it val sum anymore. And then these guys, like that. Yeah, okay, so that checks. The only issue is this. I don't think I can do it this way. I mean, it's working. I mean, it's compiling. But I don't... Maybe I can. Maybe this is just going to work. And then down here, I'm trying to think. So once we once we come back here, we should have a list of things to sum up, right? Yeah, so we can do match message type. If it's a 0, then we're going to sum. So the result of this is going to be all of values summed up. And then we're going to have to reset the vector to just contain that one value. So maybe what we do is, yeah. Okay, we can do that. We can just say new val equals value dot sum, value iter sum, and then value dot clear, value dot push new val, and then everything else I'm just going to panic just to see if this checks. That checks. So we can do the rest and then see what happens. Value iter product, value clear, value push new val. Type 2 is minimum. Oh, there's got to be an easier way to do this, right? We should be able to just pass in a function that does this without hitting F1 all the time. This is just going to be min. And then 3 is going to be max. And then packets are greater than packets. If their value is 1 if the value of the first subpacket is greater than the value of the second subpacket. Otherwise, their value is 0. All right, so we're going to assume that the input is correct, I guess. And just say let left equals value iter we want to grab value of 0. Let right is value of 1 because it's just an array, and then it's going to be 1 if the value of the first subpacket, so value clear, value push. If value is 1 if the value of the first subpacket is greater than, so left is greater than right as U64, and then we can do the same thing for less than. Five, and this becomes less than. Oops, not 4 and 5, it's 5 and 6. And then 7, because 4 is the literal value. 7 is equal. Okay, so it's just the same thing. So 7 is equal. That doesn't check. Oh, I forgot to unwrap. I didn't need to unwrap the product or the sum. I guess those always have a value. Okay. Put stars there. That checks. Do any of these tests still pass? Oh no, because they're still calling some versions. So we have to change all of these tests now. Some versions to calculate. Right? It's just calculate. Oops. Some versions calculate. And then instead of doing that, we want to say dot zero, right? Because version sum is the dot zero of the tuple. Wow, I put a lot of tests in here. Okay. That checks. Does the test even compile? Ah, and now it's running forever. Oh, AOC 2021. Okay. So I don't know which test it was failing on, although we were passing a bunch of the tests. We do have an infinite loop somewhere, and I don't know which test it is. It doesn't say here which one it was. Can we look here to see what it might be? I mean, we're not recursing in any of these guys. All right, so let's just add them one at a time. Oh, we know which ones work. Oh, well, we almost knew which ones worked. Cargo run test day 16. All right, so bits check works, can decode hex works, 3 subpackets, double recursion, 2 plus 2. 2 plus 2, 2 plus 2 different length. That one works. Triple nested 5 values. That's not here. Oh, there it is. Yeah. Okay. Bits check we don't care about. I'm actually going to remove it. Yeah, 2 plus 2 different length. 2 plus 2 double recursion is there. Oops. 3 subpackets. 3 subpackets is there. Double packet. Oh, double packet is not there. Okay, so maybe it's double packet that's not working. And then simple version. Is simple version there? Oh yeah, double packet and simple version have both been running out for over 60 seconds. Okay. So let's kill those guys. All right, so that's interesting. The simple one's not working. So hopefully it'll be easy to figure out what's going on. And hopefully it'll be the same bug that's causing double packet to fail. All right. Cargo run. Line 51 does not need to have a MUT. Okay, let me take that out while I'm here. So the simple version is just this. So this should be going through this code here. Oh. I'm not getting the next digit. So why did the other ones pass? Maybe the other ones passed all because they only had one? Yeah, and then I'm not getting the correct result here because I need to add the last digit. Okay, so then we say, yeah, so that's definitely why we need the MUT there, because we have to say digit equals iter bits to num 5. I'm glad it failed on the simple case. I'm really happy with that. Let's run that. Okay, so simple version works now. Let's uncomment all the commented out test cases. I think there's a way to say run only this test. Let's test that. Okay, all the tests pass. This is good. Now we want to add these extra test cases that find sum. So we're going to say test fn sum of 1 and 2 is going to be these 3 lines. And we're going to change this to C2, and we're going to say dot 1. Iter next unwrap is equal to 3. Did I compile? No, it doesn't like that. Oh, I can just put a star on it, right? And stop hitting F1. It's in here somewhere, right? Sum of, there it is. There it is. Okay, so that worked. That's good. Let's test the next one. I'm sure this is very boring watching me write a bunch of tests, but I want to be sure before I run my actual input. So it finds a product of 6 and 9, resulting in 54. Prod of 6 and 9. Okay, that worked. This finds a minimum of 7, 8, and 9, resulting in the value of 7. So this will test to see if our minimum function worked. Min of 7, 8, 9. And that's going to be 7. That worked. Now we'll do a maximum test. Come on, there we go. Max of 7, 8, 9. It's going to be this, and it's going to be 9. And that failed. Oh, did I? No, that's right. Yeah, CE. Okay, so we have a problem here with the max. It came up, oh, 54, it should be 9. There we go. It came up with 24. I copied this correctly. Okay, so we have a bug somewhere. All right, so left came up with 24 and the right is actually 9. So what is 24? Is that a sum? Did I do a sum instead of a... No, there's 3 is max. Min max. I mean, the min worked. And I have 3. 3 are maximum packets. And I have 3 here. And there's a max right there. Let's see if this prints out. It says max is 24. Okay. I mean, it's oh, there must be something in there that is doing fancy. Let's see what the values array is. It's just the number 24. I mean, that's a sum, right? So do we have to actually decode this thing now? Let's put this up here. Let's comment that out. Let's comment this out. Run just that one test, and now what we're going to do is we're going to have to start figuring out what this packet is. I'm going to say literal of this result. Let's see if we at least get the 3 literals of 7, 8, and 9. We do. But for some reason we're summing them. So I'm thinking we're coming through here accidentally. Println in sum. Yeah, so it's calling sum for some reason. Why would it be calling sum? Let's see if we can print in message type. And we should be seeing a 0 at some point, right? Just do that. All we're doing right now is verifying that we have the things we're doing. So we have a 3, which is, right? Oh, yeah, I think what might be happening is we're seeing like some of the bits at the end that we shouldn't be checking, and it's ending up being zeros. And so we actually end up hitting a sum. Why? Let's print out whether or not we're on the true or false path here. First. So true, true, true. False message type is 0. Okay. So are we passing through here? Packet by len of this sub packet len, or packet by count. Let's debug that. So it's packet by count 3. We're getting 3. And then we should break here before we get to this. Because it's doing packet by count 3. Why is it going more than one packet? Because it should do a literal, and then if first, break. Oh! Yeah, so for the packet count, we do want to break. Right? Maybe it shouldn't be called first then. We do want to break after that packet. There we go. Oh no, that's the wrong, that's the other tests. But we're getting this test here, max is 789. Yeah, so that was the bug. Is we don't, if we're doing packet by counts, we want to break after that first packet is done. Right, so this should pass now. This all passes. And this is why we test. This is why we test. Okay. We have one more here. Actually, we have 4 more. Let's do these 4. And this is going to be less than. And it's going to be 1. Less than works. And we're going to do, grab this, come on, yank that, place, and we're going to do greater than. And it's going to be this code here. And it's going to produce 0. Make sure greater than works, greater than works. This is going to produce 0 because it's not equal to 15. Equality. And this is going to produce 0. And that works. And then produces 1 because 1 plus 3 equals 2 times 2. All right, so this is going to be a slightly more complicated test than math. I'm starting to get excited because we're getting close to the end here where we can actually run the thing, and this is going to produce 1. And it failed. Oh, I should get rid of all those printfs. Index out of bounds. All right, so we have a problem with walking down the tree. Let's fix that. So this is a by count, it's a count of 1. Message type is 7. 7 is a quality packet, and then we have a packet by len of 80. So then we have a message type 0, which are going to be a sum packet. It's going to be 1 and 3, and it's going to sum them. And then we have a message type 2 times 2. Yeah, literal 2, literal 2. And then we failed, let's see, on line 121. Oh. This means that our packet by count didn't end up pushing both values on. Here's packet by count. Okay. Packet values are. And we just print out that that array. Okay, let's run that. So we have 2 and 2. Because this worked here, right? We got a literal 1 and a literal 3. Oh, and we haven't summed them yet? No, message type 1 is a sum. Okay. So yeah, message type 0 is the sum, message type 1 is the product. So we're actually trying to calculate yeah, it was 121. We're trying to calculate equality. And that doesn't work here. So after, it's always packet by count. We should be able to see the values that are coming in. Value extend, value extend. So we'll just print this out here. Current value is just value. Okay. We should be able to see those get pushed. Oh, now more stuff is failing? Just because I did that? Why? Wait, doing this made things break? Or maybe they've been breaking all along? This is packet by count 53. That's not right. Did I copy and paste that wrong? No. What did I break? Let's just run that one test. And then, yeah, put the current values back. Not run. I wanted to test. Oh, maybe that's what I was doing. Maybe I was just running them. Okay. There. Yeah, so current values are 4 and 2. We're doing the math test, right? Packet values 1, current values 1. Packet values 1, current values 1 and 3. Now we come down here, message type 1, which is the product packet. We have 2. current values are 4 and 2. That's not right. Oh, no, that is right, because what's happening is we're getting the 4, which is the sum, right? I bet you we're just doing the sum. Sum is new val. And then we push that on, and then we'll just put here product as new val. And we'll see that. We'll see if that works. Okay. Sum is 4. It comes here, packet. So now message type is 1, which means we're going to do product. We push the 2. We push the 2. Product is 16. And now the equality guy, which is 7, should have gotten... Oops. Equality guy should have gotten the 2. Let me run it over here so I can see. Cargo test day 16. The equality guy should have gotten the 16 and the 4. But the 4 shouldn't be down inside. Yeah, that's what I'm worried about, is the 4 is now somehow getting down inside there. But when we look at this array here, it's just going to look, it's going to look like a single value. So I messed something somewhere. Yeah, it's just seeing that 116. So it's doing a product of all of these guys. So for some reason we're pushing down this value thing. And why? Why would we be doing that? Right? We should be that 4 that comes from the sum of 1 and 3 goes in here and then should get returned on its own. So let's say println returning value this, and this should be here's returning value 3, returning value 1, sum is 4. Oh, and then it doesn't return it. It keeps going. Oh, because we have a len-based thing. Oh. So this is, yeah. This is the issue I was concerned about initially, was we have no idea how to get the individual guys here. And I can't peek in the new iter. So what I could do is I could put a true here and then keep going until the iterator is empty, but I don't know when the iterator is empty. Maybe you know what I'm gonna do is, because I'm gonna be hacking this up now, mostly working, but not really. Oops, like that. Now I'm gonna hack this thing up. I'm gonna change this to an if. So we only do one, right? And the reason we were doing more than one is because of this guy here. And now I want to be able to say, I want to be able to loop here and calculate the packets for each one of the sub packets here. But I want to stop if we're done. I mean, if there's nothing left in the iterator, and how do we stop if there's nothing left in the iterator? Now we no longer need this first thing here, because we're only going to do one. And then all the false, this goes away, true goes away, that goes away, that goes away. Okay. Any other firsts? Any other calculate packets we need to clean up? Nope. Okay. So what I want to do is be able to loop over each packet until we've used up this new iterator. And I don't, yeah, and this is where the whole thing comes into play. So calculate packets, we only call it these few times. So I'm going to say unwrap. I'm going to say option here. It's going to be a little frustrating. And we're going to say let mut decoded is false, decoded is true, and this is, there's a better way to do this. I don't know what it is though. If decoded, we're going to return this sum of this, else none. Right, and then that way, this we know it's going to work. So we'll do an unwrap on there, and then we'll say while let this sum of this, then that. And what did I break? Oh, I have two things here. Wow. Okay, so all of that actually builds. That was the problem. Okay. That test passed. Let's make sure we didn't break any of the other tests. Please, please, please. Yes. Okay, so now I think we're ready to do it with the real input. So we're going to say let version and value is equal to calculate and decode, and we're going to say part 1 is just the versions, and part 2 is values of 0. Let's run that. Oh yeah, I gotta get rid of all my printlins. All right, but we have an answer. It's pretty big, but that's the way things work in Eric land. And that's the right answer. Wow. Okay, so we did it. Let's clean this all up. Oops, I keep doing that. I want to get rid of all of these things. Printlins go away. Every single printlin goes away. I don't care about that. And these are the printlins we want to keep. We want to run that. Let's take a look just to make sure our values are right. Yep, that's still, I didn't break anything. Okay, so what, well, let's check in with Clippy, but there's a bunch of stuff we should be able to clean up. Oh, Clippy liked everything, wow. I'm excited. Okay, it's a little sloppy with this decoded thing, returning an option. I don't like the fact that we have to peek at the first value and then keep going like that, but I guess that was the way I decided to do it when I did this bits to num thing. But this all works. There's a bunch of repetitive code here. We should just be able to call a function which passes this in, the operation in. That would be nice to clean up. But this is all working. This is all good. Git add source, git commit -m day 16 part 2. And let's push that up. And unfortunately, modprog, if you're watching, I don't have time now. I'm actually way over time to take a look at your PR. Hopefully tomorrow's Advent of Code will go faster. Oh, Epic says, I feel like the Advent of Code is hidden agenda. It introduces participants into a wide array of different programming areas. Yeah, and I agree, and that's one of the reasons I do it. I mean, last year, was it? I implemented the Chinese algorithm. I forget what it is, Chinese something algorithm. It was invented by someone in China, which is why it's named that. And in order to find something, I learned about modulo arithmetic through Advent of Code. And Roger Twice says, I don't think I could deal with both sum and sum. Yes. It's unfortunate they're pronounced the same, but we understand them from context, sorry. Yes. This sum is a function which sums up the values of a vector. And this sum is something that returns a value as opposed to a none. And so, yes. Okay, but that's it. That's my stream. That took far longer than I was anticipating based on the problem description. But we got there. We did it. And now we're going to check to see if there's anybody. I'm going to pause my music so I can listen to people if there's anybody on. Add marker. No. Can we raid channel? Oh, Togglebit. Togglebit's on. Let's go raid Togglebit. Let me pull him up real quick. There he is. And good thing I don't have to listen to an ad. All right. All right. Take care, everybody. And I hope to see you tomorrow for day 17. Thanks for watching.